Hi students, welcome back. Today we are going to look at another problem on LeetCode called the search in a rotated sorted array. So we have seen searching in a sorted array using binary search. Here it is a rotated sorted array. So we are given a integer array nums sorted in ascending order prior to being passed to the function. Nums is possibly rotated by an unknown pivot index. So let's say we are given array 0, 1, 2, 3, 4, 5, 6, 7. It might have been rotated any number of times. If it is rotated one number of times, 0 will go to the end. Two number of times, 0 and 1 both will go to the end. 3, 0, 1, 2 will go to the end. So if it is rotated three times, then it becomes 4, 5, 6, 7, 0, 1, 2. Okay. Given such an array, we have to find a target in that array. So if at the target exists in nums, we have to return the index of that. If it doesn't exist, we have to return -1. Okay. And the important thing is we have to write this in order of log n. Okay. Now let's see the some examples. So if the input is 4, 5, 6, 7, 1, 2, 3. So it is pivoted three times. So this is one part of sorted array. This is one part of sorted array. The target is 0. 0 is at index 0, 1, 2, 3, 4. 4. This is at index 4, which is why the output is 4. Let's say the target is 3. It doesn't exist in this array. That is why -1. Similarly, here also the target doesn't exist in the given array. That is why -1. Okay. So the important point to remember is we are given a rotated sorted array and not a regular array. Our agenda is to find a element in that array with log n time. Okay. So let's see how we can do that. Let's see. Let's take an example. Okay. Let's say that we are given 4, 5, 6, 7, 1, 2, 3 and the target is 1. So to start with, let's give indexes to this. Okay, let's call this 0, 1, 2, 3, 4, 5 and 6. Okay, so initially when we started, uh, so if it is a binary search, right, what will we do? We will find the middle element. We will see if target is on the left side or right side and we will eliminate that half. So it is guaranteed to exist on the either the left side or right side based on the mid element. That is because it is already sorted. Here it is sorted, but it is pivoted. So it's not, for example, if you are looking for 1 and the middle element here is 7. Okay. 1 is less than 7, but it won't exist in the left side. Okay. There is no guarantee that we will find this in the left side. Okay, that is because it is rotated. So a simple binary sort will not work in our case. But since it's a order of log n algorithm, we definitely have to eliminate one half of this. Okay, uh, so this will be low, this will be high, just like in binary search. So how can we eliminate half of it? So if you observe here, you can see that one side of mid is always sorted. Okay, here both the sides are sorted. That is a special case, but one at least one side will always be sorted because it is only pivoted. So at least one side is guaranteed to be sorted. So if we can find the sorted side, so step one is find sorted side. Okay, and in that check if target exists in that. Okay, we have to find a sorted side, and in that side if the target exists, so it is sorted, so we can easily check the boundaries and figure out, then that means our element is on that side. Let's say we found a sorted side and target doesn't exist on that side, then our element will exist in the other side. Okay, so the important thing is not just looking for greater than less than, but finding the sorted side and checking if our target is in that side. So if those two conditions satisfy, then we found the side in which our element lies. So let's draw a dry run with this. Okay. So we are looking for target. So the first step is to find a sorted set. How do we define sorted set? So a sorted side is something where the lowest element is less than or equal to the highest element. Here the lowest element is, so let's look at the left side of the array. Okay, lowest element is 4. Is 4 less than or equal to 7? Yes. So left side is a sorted side. Okay. Now we found a sorted side. What is the other check we have to do? Check if target is in the sorted side. How do you check if target is in the sorted side? We have to check if target lies in this boundary condition. Does one lie between 4 and 7? No, it doesn't. Which means though the left side is sorted, our element doesn't exist in that side. So we have to move right. Okay. How do we move right? We move right by changing low to mid plus 1. So this becomes a new low. Okay. Now that is our new low. We have to find a new mid. Okay. Now we have low as 4, high as 6. Mid would be low plus high by 2, which is 5. So mid will come here. Now, at any point to start with, we missed this earlier. We have to check if target is equal to mid. If that is the case, we don't have to do anything, right? We can just return the index. Okay. So first check if target is equal to nums of mid. That means is 1 equal to 2? No, that is not true. So target is not equal to mid. So again on the left we have to check if left side is sorted. Left side is low to mid. Is 1 less than or equal to 2? Correct. So left side is a sorted array. Does our number exist in that? Yes. So our element is on the left side of the uh, array now. So that means our element is in low to mid range. Okay. So we have to move high to mid minus 1. Okay. Mid minus 1 is nothing but 4. So high also will come here. Okay. Low, high. So mid also will be here. So next time we do mid equal to target comparison, it satisfies and we return the index. So what is our algorithm here? The first step is we have to check which side to eliminate. Check which side to eliminate because we have to do it in log n. There is no other way. We have to compare the mid and check which side to eliminate. Okay. How do we do this? We first check which side is sorted. Which side is sorted. Once we find the sorted side, check if element exists in the sorted side. Exists. If it exists, this is our new, the other side is eliminated basically. Okay. If it doesn't exist, then else this side is our, the other side is our, what is it called? New target. Okay. That is how we reduce it by half every time. So every time we check which side is sorted. If the element is in that side, then we take that side and proceed with that range. If the element is not in the target, we take the other side. So either way, we are eliminating half of the array. Okay. So now let's write code for this. Okay. So now it is a simple binary search. So we obviously need two things, low and high. Okay. High is nums dot length minus 1. So while low less than or equal to high, you should also check for equal to, because there can be a case where there is only one number in the resultant. We have to find mid. Mid equal to low plus high by 2 or low plus high minus low by 2. This is to eliminate the integer overflow which we discussed in the other video. Okay. Now once we have this, the first check is we have to find if mid mid is equal to target. If that is the case, then we just have to return mid. Okay. If that's not the case, then we have to figure out a sorted side. How do we figure out a sorted side? We have to check if only at least one side is will be sorted. We have to check if left side is sorted. How is the sorted check? If nums of low is less than or equal to nums of mid, that means the lowest element on the left side is less than or equal to the highest element on the left side. That means left side is sorted. Now, if left side is sorted, we have to check if our target is in the left side. So, if nums of low is less than or equal to target and target is less than nums of mid. Okay, we can also check for equal to here, but we anyway did a equal to check. So, that is not needed. Okay, if this is the case, that means our target lies in this side of the array. Okay, then we have to, which is left side of the array, right? So high moves towards the left, so high equal to mid minus 1. If this is not the case, then our element lies in the right side of the array, so low moves to mid plus 1. So in this case, we have processed the condition where left side is sorted. Now, what if left side is not sorted? Okay, that means right side is sorted. Okay, we need not check the condition again. We can just do it else because one of them will be sorted. Now, if right side is sorted, we have to check if the number exists in the right range, which is if nums of mid is less than target and and target is less than or equal to nums of high. So we are basically checking if target is between nums of mid and nums of high. If that is the case, then we have to search for the right side of the array. So our low becomes mid plus 1. If that is the not the case, though right side is sorted, element is not there in that clearly, which means we have to go to the left side of the array. How do we go to left side? We move high to mid minus 1. Okay. And that is how we continue processing until we find our element. At some point, we will find our element at mid and we will return that mid. So after we finish this processing of the entire array, if we still didn't find it, we have to return minus 1. Okay, let's run this and see. Okay, yeah, let's submit this. Okay, our answer is accepted. So that's all we have for today's video. So it is a simple change to binary search problem. In binary search, we basically do only this check. Here we have to do that check twice by figuring out which side is sorted. Okay. Do practice with few more examples so that you understand it better. Thank you for joining. See you in the next video.